Saxon Calculus Lesson 99 is about the average value of a function and the mean value theorem for integrals. Now, I have given you a new equation here, which is basically doing an integration from a to b for a function with this extra multiplication in front of it of the b minus a as a fraction where that's in the denominator. And when you do that formula, you have found the average value for the area under a curve. And so on the top of 484 is a box. Definition of the average value of a function is this formula. And it says if f is continuous on the closed interval called I, from a to b, not including the a and b, where b is greater than a, then the average value of the function is this. Now, example 1 says, find the average value of the function f of x equals x squared minus 10. X squared minus 10. Okay. On the interval between -1 and 2. Yes, you can see that. Okay, so now we are going to plug this into the formula. So we are going to integrate from the -1 to the 2. And obviously the formula is x squared minus 10, technically dx. And our extra piece here is 1 over top of 2 minus the -1. So minus the -1 is, of course, +1. 2 plus 1 then would make that 1/3. And then when we integrate, this becomes 1/3 x cubed minus 10x. Sorry, that's hard to read. And we are still plugging in from -1 to 2. And we will multiply that by the 1/3 that I had in front of just now writing here at the back. So 2 plugged in is 8. So we now have 8/3 minus 20. And then minusing from that the smaller number, -1. So that's -1/3 plus 10 because of the sign change. And we're still multiplying all of that by the 1/3, so technically that should be like in a bracket. I started to say common denominator, but basically you can or do that on a calculator. And so we should end up with, and I'm kind of mentally trying to check it, minus 60 negative 50 something. That would be 30, so 20, so -50 plus a 20 something. Yeah, so they're getting -27 for all of that. And then 1/3 times -27 should give us the answer of -9. So hopefully that works out on your calculator. Let me just see if I can find those numbers just to make sure I've not boo-booed something. Yeah, we're good. Okay, example 2. Approximate to 2 decimal places the average value of the function f of x equals 4e to the 2x on an interval from 0 to 3. So we are going to 1 over 3 minus 0 is 3. Integrate from 0 to 3, the equation 4e to the 2x dx. And then the integration of that would give us the 1/3 multiplying with, 4 is a constant. Let me pull it out to make 4/3. And then that's e to the 2x, and then it would be 2, so we make it 1/2, and we're obviously, well, let's fix that. So that's going to be 2 going into 4, so 2/3 with our e to the 2x plugging in the 0 to 3 and still multiplying with that 1/3. So then 0 is going to not be needed, and then we plug in the 3, so definitely calculator that. So that would be e to the 6th power, and that would be a decimal, multiplied by 2/3. And then you should, oh, 1 second. I said e to the 0 went away, but that is incorrect. So in this case, that 3 should give me the decimal 403.43 minus, and there is an answer here with the 0 because e to the 0 is 1 times the 2/3, and then the 1/3, so that would be, they're getting 1. They're saying 2/3 plus 1/3. No. Just a second. When I rewrote that, I'm not 100% sure I wrote that in the right format. That was my 1/2 multiplying with my 4/3, which was turning that into the 2/3. Don't multiply with that yet. Yes, okay. So this one, which was 1, then multiplies and gets the 2/3. Trying to use their number, I'm now not confident that this is the right decimal, but they're saying they have 403.43 minus 1 and then multiplying with the 2/3. See, I did mine differently than theirs, so I won't guarantee this number. Whatever that works out to be on your calculator then, just follow that, and the final answer still should be the same, 268.29. Okay, now part B is the mean value theorem for integrals. So back to this original equation, we now call in the box mean value theorem for integrals is the exact same fraction, the exact same integration. The only change is that instead of saying v of a, it's f of c. Even though there's no c in the rest of it, it still works with that same formula. So the definition of the average value of a function and the mean value theorem for integrals is basically the same thing. So example 3 says, given that the average value of f of x is 2x cubed on the interval from 0 to 3 is 27/2. Use the mean value theorem to find a number for c, and remember that in the mean value theorem it's f of c, not f of x, such that f of c gives you this 27/2. So we are using our 2x cubed set equal to our 27/2, dividing by 2, and then taking the cubed root of that on the calculator will give you 1.89 or something fairly close to that. And that is a value for the c that makes all of that work. And we do see that 1.89 is somewhere between 0 and 3, always a good thing to check. Now part C is the proof, and you are more than welcome to walk through it. It is not the normal derivative formula plugged in with things. It's a lot of comparing things falling between, like the c value has to fall between a boundary, and then they draw this final conclusion. So again, you're welcome to read through it if you desire to do so.